Hello everyone, welcome to 2-Bit Studios, and this is going to be the episode number 2 of the MegaGrid plugin tutorial series. In this video, we'll be talking about populating a grid with tile types. Now, in the previous episode, we actually had created random obstacles in our grid towards the end of the video, and I did give you a challenge to try to change the shape of the grid. If you have been able to do so, congratulations. If you haven't been able to do so, it's pretty simple. You can come to the Grid Manager actor once again, and under the Grid Shape panel, just hit the drop down and you can change the shape. So I can go back to square and I can come back to hex once again. Tile types is an important data point because tile type is going to be used for most of the interactions you're going to be creating with this plugin. Let's say you want to place buildings in a certain area, well, you will have to create a grid and map or set the types of those specific areas to be a building zone type. And then you could sort of hover over the building and you can place the building, but you would check if that tiles have a compatible tile type. And obviously tile types are very important for pathfinding as well, which we'll cover in a different video. Tile types have movement costs associated with them as well. In order to create custom tile types and states, we can come, it's pretty simple actually. We can come to the MegaGrid content once again, and in the data folder, you can see two data tables. Currently, I'm only going to cover tile type mapping. So I'm going to open that up. I've already created a new type called my type, and make sure the tile name and the row name matches exactly the same. We can also add movement costs again for pathfinding. We can also add tile color with the functionality for faking transparency if your alpha is less than 1. So with that said, again, adding a new type is pretty simple. Create a new type. I'm going to call it tutorial type. Copy that, and tile type name is going to be tutorial. Okay, I couldn't copy that. Tutorial type. The movement cost is going to be 50, and the color is going to be magenta. Cool. So that's pretty much it. You have created your very own tile type. Pretty cool, right? So to see it in action, we have to understand the methods used for assigning types to your grid. There are 3 methods currently available. One is using the manual method of using the tile editor mode. To access the tile editor mode, you can come to the editor mode drop down, and you can see that there's a tile editor mode. I don't know why I'm having a little bit of glitch here, but anyway, you can click it and you'll enter the tile editor mode. You have an array of functionality here. You can add the type, remove the type, clear all types, and this checkbox is relative to the button you're using. I'll get into that later. Just to show that we have created a new tile type, I'm going to click the add tile type button, and the select type, we can see that tutorial type has been added. So I can click the tile type, tutorial type, and then I can start painting. So now as you can see, we are adding a new type into the level. So this is the first method of assigning types. It is time consuming if you're working on larger grids. So I do only recommend this if you want the highest level of control, but only up till 15 to 50 grids. While we're at it, let's also check the other buttons as well. So this is the remove button. We can remove the tiles, and the clear all types again is relative to the button that is active. So if I clear all types, you can see that whenever I hover over the obstacle type, it doesn't get removed because we're not removing all types. We're only removing the specified type. So the current selected type, tutorial type, only that will be removed. If I change it to obstacle, now only obstacle will be removed. We can clear all types as well. you can see all the, let me resize the window, the entire obstacles vanish from the grid. But if I change that to my tutorial type and hit the clear types button, we can see the tutorial types have also been cleared. Now, one distinction to note is if you're clearing types in the tile editor mode, the tiles do exist in the level. Their types have been just reset to default. As you can see with the outline of the instance static meshes, they still exist in the scene. The data just have been reset to default settings. If you come to Grid Manager and then hit Destroy Grid, this would remove the data and the visuals together. Here we are only resetting the settings in the tile editor mode. We have brush settings as well. We can increase the brush size. It works for both hex and square grids. We can also fill only empty, which means, let me quickly create random obstacles in the Grid Manager. And now if I have only fill empty activated, we can sort of mindlessly brush through our grid without the concern of overwriting existing tiles. So you can see the obstacles do exist without being overwritten, but if I uncheck the fill only empty, the obstacles will also be overwritten. The tile editor is pretty much self-explanatory. Play around with different settings and different buttons. I think you'll figure it on by yourself. Moving on to the second method of mapping your tiles is called automapping functions. And you can already see that there's a boolean called automap types. If I check that and create grid in my grid manager, nothing really happens because there's nothing to automap. Automapping functions works with the requirement of a guide. So you need a guiding actor or a mesh to map the tiles beneath it. For example, let's actually start with a default cube and reset its position to be the world center, so it fits perfectly with the hexagon center. Now imagine that I want to map the center hexagon to be the tile type of the cube. For example, if you're building a game where you have buildings and structures and whatnot, imagine that this cube is a building and you want the tile beneath it to represent the type of the building. So in this case, let's say the type is going to be high rise or a tower or some sort. So in this case, I'm actually going to use the new type that we created. So this building is going to be of the tutorial type, and we need to map the tile beneath it to be of the type corresponding to the actor that is placed above it, if that makes sense, right? In order to do that, the first step is you need to configure the collision. So let's go into the collision settings. And if you remember in the last episode, we actually created two new trace channels. One is for the grid surface, which we are using currently, and the next is the automap. Let's go inside the collision presets, change it to custom. And here, let's drop it down. And here we have the automap set to ignore. Let's make it to block. Next, we need to add the tag. So let's come here and add the tag again under the actor tags, not the component tags. And what is going to be the tag? Well, the tag is going to be the row name of the tile type you want the actor to be. So in our case, let's go back to our tile type table. Here we have created tutorial type, and that's why I said the row name should be exactly the same as the tile type name. So we can simply copy the tile type name and we can put it here. Well, now it should work, right? We can come back to grid manager, create grid, and nothing really happens. That is because we have to tell grid manager to look out for specific types to map. And in order to do that, let's come all the way down to the core dependencies, and we'll see something called types to automap. And we have to add a new type, which is going to be the type we are targeting, the tutorial type. With that done, let's save it, come all the way up to the default section once again and hit create grid. Now once I hit create grid, you can see that we have the new type mapped to the object above it, right? So if I move this object to be, it doesn't have to be snapped to the grid, it can be anywhere pretty much. And if I hit create grid, well, now nothing really happens. And that is because by default, the auto mapping function uses a line trace at the center of the tile location. So you can see if I go over the hexagon tile, it's roughly over. You can see if I'm shooting a line trace from the center of the tile, I am obviously missing the object. The solution to that is pretty simple. You can come to the grid manager settings all the way down to, where was it? Yeah, grid generation, and use shape trace. So you can click shape trace, and now if we hit create grid, we should sort of have a little bit more accurate information about where the object is. That is because we're using a shape trace rather than a line trace. For hexagon, it's a sphere trace, and for a square grid, it's a cube trace or a box trace. If I sort of move it here, we should see sort of these two tiles light up in the new type. Yeah, so these two types are now of the tutorial type. So this is one way to populate your grid with tiles or types. And I recommend this method because imagine having a lot of actors already spawned in your level, and this can go in conjunction with, say, a procedural algorithm for placing actors in the scene, and immediately afterwards you can use the auto mapping function to instantly assign types to your grid. So this is certainly one way to do it. Let me try with cylinders as well, just to show you that you can sort of use literally anything, and the cylinder is also going to be of a different type. I'm going to increase the size a little bit. Your mesh doesn't have to be really sticking to the floor, but in most cases I think developers will want to have it sort of snap to the floor, maybe like a building game or like an XCOM game where obstacles are obviously stuck to the floor. But you can also use this as simple guiding meshes, which is what we'll get into the next step or the next method. But for now, I'm actually just going to do the exact same procedure. Gonna go for collision, custom, and then auto map activate. And then for tags, we can come over to actor tags. This time, let me add a different tag. Let me add the special tag. And that's pretty much it. We can come back to grid manager and hit play. And obviously I've missed the third step, which is to add the type in the grid manager as well. So in the types to auto map, we can add special, and then we should sort of have all the area under the new object set to the specified type. So if I move it around, rotate it, whatever, I can still accurately sort of map it. Obviously, there are going to be cases when there are going to be bleeds into the neighboring tiles when you have complex collisions and stuff. Currently, we're using very simple collisions like our default shapes. In cases where you use trees and stuff like I did in the demo game, I had a little bit trouble going on with neighboring collisions and stuff. You can fix that really easily again by coming to Grid Manager and search for something called Hex Extend. Hex Auto Map Extend, again inside Grid Generation. If you're looking for square, you can look for square. But again, currently we are looking at Hex Auto Map. And I can sort of increase and decrease this value. If I put 0.3 or 0.5, we should sort of have a little less accurate mapping. So this cube has been completely missed by these two tiles, because you can imagine the radius being only till here, and both of them will definitely miss it. And even in this case, we have a little bit more accuracy. So if I move the cube to be roughly there and hit, yeah, now we have one tile sort of corresponding to that map. Maybe I should drag it a little bit down to see that better. Yeah. So again, you can increase the value as well, hex auto map. And if I put it at 1, you will see how drastically the neighboring tiles are affected as well. So there we can sort of see the entire region has been affected. And I think that's quite accurate, to be honest. Yeah, and that is how you can auto map your types using the auto mapping function method number 1. The second method is using blocking volumes, which is pretty much the exact same as using your custom actors and meshes and whatnot. But blocking volumes, again, you can come to volumes inside the MegaGrid content blueprints, and you can drag a blocking volume into the scene. By default, it'll be a cube, but you can simply hit the default checkbox and it'll become a hex. You can sort of rotate it and adjust the transform so they sort of roughly match with the tile. Now, the only advantage of using a blocking volume like this is that you're saving performance by avoiding shape traces. Shape traces are somewhat more expensive than simply using line traces. And in cases where you're using the max limit of 90,000 tiles, using shape trace in runtime specifically is going to bog your system quite a lot. In that case, you would pre-place all the actors into the scene, but that also comes with the question, how many actors are you really going to use, right? Unreal Engine and a lot of actors don't go well together, but it's still an option to use blocking volumes. So I can come and click the blocking volume and do the exact same procedure. We can come and set the collision, and this time we can't really find the collision, and that's because we need to select the static mesh component, and then again block all dynamic custom and set the auto map to be true. And then we can come to the tags. Again, we'll add the exact special tag, and I'm going to show you the difference of using a blocking volume plus a simple line trace versus a shape trace, right? So we have already seen the shape trace being quite accurate, but if I had to disable the shape trace and hit create grid once again, you can see the accuracy sort of falls off quite a bit. But here we are not generating anything. Is my collision proper? Auto mapping is set to true, and tag. Okay, so that's a normal mistake that I made. I sort of added the tag to the component tag section rather than the, so let's delete it and come to the blocking volume itself and then add a special tag. That's a common mistake that even I fall to. And now we can sort of come back and see the difference. So now you can see that the blocking volume is far more accurate because, again, we are taking the exact shape of the tile, and because of the line trace, we're actually saving on a lot of performance as well compared to the shape trace with custom meshes. The next thing we have to cover is actually saving your grid. This is actually a very important topic that I have to cover here, because usually what would happen is you would populate a tile, you spend hours on your grid, and then you would sort of like, okay, I'm going to hit Control S and then I'm going to close my project. But then when you open your project back again, your grid has been disappeared. The saving system has to be done manually by the developer by coming to the save handler and then hitting save grid. So whenever you do make changes to your grid, you have to be sure to hit the save grid button, because again, we are using an editor based system as well as a runtime system. So when you do close the game, every data from the memory will be erased. So you have to make sure that you're saving it to the .save file. So every time you make changes to your grid, you have to come here to the save handler, save the grid, and then Control S as well. And the Control S part is making sure that the grid manager settings are properly sort of saved, so the exposed variables. So that's pretty much it for this tutorial. We covered populating your grid using auto-mapping functions, tile editor, and also covered the standards of saving your grid. With that said, I'll see you in the next video.